So let's start with the definition of an ellipse again. All these conic sections start off the same. It is the set of all points in a plane, okay, comma, and this is going to make more sense after we saw how it was built. The sum of whose distances from two fixed points and those fixed points are called what? Foci. The sum of the distances from the foci, comma, is constant. Okay, and so for example, here is an ellipse, and I've got the two foci. Here is focus point 1, and here is focus 2. And all of these points around the ellipse, those are the points that make the ellipse. So here's a point, and the set of points where the sum of the distances, so this distance, I'll call it D1, and this distance, which I'll call D2, D1 plus D2, I'm just going to pretend that it equals 10. So all of the points have the sum whose distance is 10. For example, here's 1, and here's 1, and these two also would have to add up to 10, the distance to the foci. We have something else too. If you start at the center of the ellipse and you go a distance to the foci, that's going to be called r. It's a radius, but it's not r sub x, it's not r sub y, it's r sub f. So that's something new we're going to talk about today. So the definition of focal radius, r sub f, is the distance from where to where? It always starts at the center, distance from the center, and then where does it go to? It goes to the foci, and it goes left and right. There's another r sub f going that way. Here is an important equation you must study. Okay, r sub f squared equals r major squared minus r minor squared. So for example, if we have an ellipse, and we have the focus point right there, if the r sub f is 4, and the r sub x is 3, and then the r sub y all the way to here, r sub y is 5, we can do a calculation. So if r sub f is 4, the focal radius is 4, the radius in the x direction is 3, and the radius in the y direction is 5. This is the exact one that we built yesterday. Okay, you can calculate the focal radius here. Let's just prove this. R sub f squared. Of course it's major minus minor. So of these two, of x and y, it's always going to be the major one squared, 25, minus the minor one, minus 9. So r sub f squared is 16, and the focal radius is 4. So what we're doing is we're taking the x and the y, and we're doing the big one squared minus the little one squared. This is a 3, 4, 5 triangle. So that's why it's going to work. This is the Pythagorean theorem. This is the right triangle. Okay, so what we're going to do, starting today, is we're going to graph the ellipse as well as the foci. So let me ask you some questions. What is the center of this ellipse? Yes, 0, 0 is correct. How about r sub x? R sub x is 5. How about r sub y? R sub y is 13. How about r sub f? I'm going to have to do a calculation for that. Okay, here's my work on the side. R sub f squared. I have to do one of them squared minus one of them. So 13 squared, of course, makes 169. So sometimes people just look right here real fast. 169 minus 25. R sub f squared is 144. And so the focal radius is 12. Okay. Let's see. Let's give you guys a minute here to maybe get the picture going. It's at the center. The r sub x is 5. 1, 2, 3, 4, 5 to the right. 1, 2, 3, 4, 5 to the left. So everything's just like yesterday. The center r sub x, r sub y. I think this graph paper is 15 units long. So 13 would be right here. I counted the boxes when I made it, so that's why I know it's 15. Okay, so here is the nice tall ellipse. Okay, now the focal radius has a length of 12. Can we put the foci outside of the ellipse? Of course not. The holes that we poked for the dental has to be inside the ellipse. Okay, so we're not going to go on the x-axis, we're going to go on the y-axis. So you go up 12 units right there, and you put F for focus. Down 12 units, F, there's focus number 2, your foci. So are the foci always on the y-axis? No, not necessarily. Okay, you don't get to pick where you put them. How do you know where the foci go? The foci are always on the major axis. They're always on the major axis. So if your r sub y is bigger, that's where the foci are going to be. Okay. What else do we have here? Yesterday, we learned an eccentricity formula that says r major squared minus r minor squared. Now we can simplify this formula a little bit because the radius major squared minus the radius minor squared is actually r sub f squared, the focal radius squared, divided by r major. So we can go ahead and simplify this formula a little bit. Okay? Since focal radius squared can be substituted in there, the eccentricity for an ellipse actually got a lot easier. Square rooted r sub f over r major. R sub f over r major. So it's focal radius divided by the major radius. Okay, so let's take a look at this ellipse and let's find his eccentricity. R sub x is 5. R sub y is 13. And r sub f, we just calculated on the last problem. This is the same as the last problem was. R sub f is 12. Okay, so we have the focal radius being 12. So eccentricity is focal radius over major radius. The focal radius is 12, and the major radius of these two would be 13. There you go, eccentricity. And remember yesterday we said the eccentricity of an ellipse is between 0 and 1. Is this a good answer? Yes, good answer for ellipse. The closer the number is to 0, the more like a circle. And the closer the number is to 1, the flatter the pancake. So this one's not very circular. I would agree, this is not very circular. It's pretty long. Okay. Oh, great. We get to complete the square here a little bit. So we're going to get things all lined up. Let's put our x terms together first. 4x squared plus 8x. And then let's get our y terms. Plus 3y squared plus 6y. And I'll move the constant to the right. So I don't think it's time to start halving and squaring just yet because we have to get that x number alone. So we're going to factor out a 4x squared plus 2x. And here, plus, let's factor out a 3, leaving us with y squared plus 2y. Okay, 5, you just hang on a second. Now, halving and squaring time. Half of 2 squared is plus 1. But it's not really a plus 1, that's actually plus 4. So let's add 4 to the right as well. Half of 2 squared is plus 1, but that's really a 3. Let's add 3 to the right as well. So 4 times x plus 1 squared, just time to factor a little bit. We have the quantity y plus 1 squared, and this equals 12. standard form, I have to divide each and every one of these by 12. Okay, 4 can cancel with 12. That makes a 1 and a 3. A 1 and a 4. So in standard form, we have x plus 1 squared, quantity squared over a 3, plus y plus 1 quantity squared over a 4, and it equals to 1. So there's your standard form, and we could be able to find a lot of information now. So the first thing I would like to know, where is the center? Negative 1, negative 1. R sub x. R sub x is radical 3, which is approximately, is it 1 point something or 2 point something? It's 1 point something. R sub y is 4. And starting today, we're also going to be plotting the focal radius. So we have to do a focal radius equation. So focal radius squared is the major 1 squared minus the minor 1 squared. So r sub f squared. So you can look here and square them. Oh, I made a mistake, didn't I? How come no one told me? This is supposed to be a 2. Ah, thanks. Okay, r sub f squared. The major one would be the 4 minus the minor one, which would be the 3. I like to look right there in the problem. Some people like to look at these and square them. Okay, so the focal radius squared is 1, which means r sub f is 1. Okay, we also want to, let's see, find the focal radius. Got it. I have to graph the foci. I will. Oh, and find eccentricity. Okay, so let's state the eccentricity then. Eccentricity is focal radius 1 over the major. Not the square, just the regular. So who is bigger, 2 or radical 3? 2. So the eccentricity is a half. Okay, eccentricity doesn't get graphed. That's just a fact that you know about the ellipse. So where does this ellipse go? The center's at negative 1, negative 1. R sub y is 2, so 2 units up, 2 units down. R sub x is 1 point something. 1 point something. So I don't want to be just at the box at 1. I don't want to be quite to 2. So here's the ellipse. And the only other thing we need to add on are the foci. The focal radius is 1, and it goes on the major. The major is r sub y. So that means the foci are going up and down. So 1 unit up from the center, here's one focus point, and there's the other focus point. And that's everything about an ellipse. The only other thing we can do is possibly write an equation. If I give you information, don't forget, a picture is worth how many words? Okay, then let's draw one. The equation of ellipse with the foci. Okay, we're going to be getting a lot of things here. Center, vertices, endpoints, foci. So let's label things. The foci are 0, negative 3, and 0, positive 3. 1, 2, 3. Okay, I'm going to label that with an F. That's a focus point. 1, 2, 3. Focus point. Okay. Just looking right here, there's a bunch of stuff you know. So I'm just going to stop reading the problem and I'm going to write down everything we know. For example, can you tell me where the center is? Great. C for center. Okay, so the center is at 0, 0. Okay, go back at that. Look at that picture. There's other things you should know. Do you know which axis is the major axis? Remember, the major axis always has the foci. So this ellipse is going up and down. So R major is going to be the y-axis. Okay. Do you know R sub f? R sub f is 3. Okay. And let's see. How about R minimum, or the minor? Who's the minor axis? X. Okay, great. That's a lot of information just off of one fact. Let's get some more information. The minor axis is length 4. Okay, the minor axis is the x-axis. So looking at this picture, if you go left and right, that length, That length is 4. Left and right is 4. So r sub x must be 2. R sub x is 2. Okay, we've got r sub f. We got r sub x. The only one we don't have is r sub y. But we do have a new fun formula for focal radius. So the focal radius squared equation says you take the major 1 squared minus the minor 1 squared. Of course, big minus small. Do you know the focal radius? Yes. So r sub f squared would be 9. Do we know the major one? The major one is y, and we don't know y. We don't know r sub y, so I'm just going to write r sub y squared. Do we know the minor one, or r sub x? We do, and that squared would make a 4. So I'm going to add 4 to both sides. R sub y squared makes 13. So that means r sub y is radical 13. Remember, we're trying to write an equation. To write an equation, there's 3 things you have to know. Let's just remind you. Need to know. In order to write an equation, number 1, you have to know the center. Number 2, you have to know r sub x. Number 3, you have to know r sub y. Once you have those 3 facts, you can go ahead and write your equation. Quantity squared plus quantity squared equals 1 with the 2 fractions. That's standard form right there. Please take a second to go ahead and fill in this information. Okay, let's see if you got it right. Since the center is 0, 0, we don't need any numbers other than x squared, y squared. R sub x is 2, so under him let's put 4. Under y squared, I will square the square root and get back to 13. Excellent. Okay, let's draw this again. A diagram of the story will help get some of the information going. Sometimes one fact, looking at the picture, can give you 3 bits of information. So the vertices are negative 4.5. 1, 2, 3, 4. Negative 4.5, negative 4. That is 1v for vertex. 1.5, negative 4. V for vertex. Okay. Well, looking at this, oh, hang on, negative 1.5. Negative 1.5 is here. Sorry, V for vertex, ignore this. Oopsies. Okay, looking at these vertices, we should be able to find the center, no problem. Okay, some people insist on doing midpoint calculations. Some people just like to find the center with the picture, half unit over, 1 unit over. So the center must be right here, C for center. So the center is at negative 3, negative 4. Okay. And let's see, I still don't know which way this is going. Let's read some more. The major axis endpoints are negative 3, 0. Oh, that makes sense. Negative 3, 0. And negative 3, negative 8. Well, that makes sense. 4 units down. 1, 2, 3, 4 more units down. Okay, so that means up 4, down 4. That means r sub y is 4. Okay, so I can see the ellipse right here. There's 3 things you need to know for an ellipse. The center, got it. R sub y, the only thing left is r sub x. Looking at r sub x, it is... Okay, all right, I guess it's 1.5 decimal people. But how about in terms of a fraction? Okay, good, 3 halves. you need to do fractions. You can't put decimals into your standard form that has fractions. Okay, so since the center is -3, -4, that's going to be x plus 3 squared, and then y plus 4 squared equals to a 1. And now it's time to just put our r sub x, r sub y squared. So r sub x squared, square the top, square the bottom, 9/4. R sub y squared is 16. Okay, if you understand that much, you are almost done. What? I thought we were done. Well, hang on. We can't leave a fraction in the bottom of a fraction. We have to clean up this triple decker. A couple ways you can do this. I can multiply by 4 in the bottom. Then I'd have to multiply 4 on top. Some people think, well, when there's a fraction down there that the number comes upstairs, and you're correct. I don't care how you do it, but the final result is 4 times x plus 3 quantity squared over just a 9 plus y plus 4 quantity squared over 16 equals 1. And this is exactly how you have to write the final answer. If you ever see something like this and there's a number upstairs, what do you do with it? Well, then you bring it in downstairs. It becomes part of your radius. So if you have a number down there, make sure you clean it up for standard form. But if I said, what's r sub x? Don't say 3. You'd have to bring that 4 down there, so you could say 3/2. Okay? Just a little something to be careful of with fractions. Have a great day.